The biggest challenge facing mankind is how to feed 10 billion people. Until 400 years ago, we lived like every other animal in the limit of food supply, depending on the sun to cause photosynthesis and provide the food we eat. But then we discovered a buried form of sunshine, concentrated energy that allowed us to transform our economy. That was the product of photosynthesis that had been fossilized and stored away. And unleashing that energy allowed us to fundamentally change the way we live. And now the biggest challenge we face is how to feed all those people without doing yet more damage to the environment, so that our grandchildren and their grandchildren have something to enjoy.
One of the key challenges that are faced by mankind at the moment is the issue of climate change. As a university, we are working very hard and in an innovative way, whereby we develop new models, new framework, new technologies, new systems in order to help various stakeholders across the world, across sectors, to reduce the environmental footprint.
The technology is there. The key challenge is really how we bring the society and industry to realize that there's huge potentials.
One of the key factors is actually understanding how people respond to some of the newer technologies. Actually gauging a little bit more about what they understand from this, their levels of acceptance, is going to be fundamental if we are going to employ this as a technology.
Here at the University of Sheffield, we're trying to reconnect the plants and the soil. We're doing research to make plants that need less fertiliser and less pesticide, so that agriculture can coexist in a grander ecosystem and provide food for all. Project Sunshine collects a whole bunch of different research areas: solar physics, photovoltaics, photosynthesis, plant physiology, ecology, and brings them all together to synthesize a bigger research project from all the detail, to put it in the context of the world in which we live, to answer big research problems. The key areas of focus for Project Sunshine are understanding the sun, understanding how we collect energy from the sun, understanding how plants transform that energy from the sun into food we can eat. Research generally needs detail, and detail's often undigestible. In Project Sunshine, we bring many areas of research together in order to tell the story of the value that the University of Sheffield delivers wider, socially and globally.
The university is a hotbed of knowledge and innovation provision for all types of stakeholders around the world. We have researchers from the social science school, we have researchers from science, we have researchers from engineering, health and humanities and the digital technology area to come together to form this team in order to address this challenge.
I think we have a lot of expertise, a lot of technologies drawn from many industry sectors. And actually I think there is a pool of information here which you can draw on in terms of expertise, facilities, equipment at many levels.
So this is our Grow Dome. It's a £1 million greenhouse, part of the big investment we've made in research in the environmental area. And it houses many kinds of research, including our cutting-edge research on synthetic soils. How can we recreate the environment of a soil on the side of a wall so we can grow green walls? These are ideas that come from bringing people together, investing in cross-disciplinary research. So in this room, we're doing research on sub-Saharan agriculture, how growing plants together can improve plant yield. And the things we learn in this piece of research, we can bring back to benefit the agricultural industry in the rest of the world. The biggest agrochemicals company is Syngenta. We work with Syngenta at various levels, and we will use that research to bring forward together a more environmentally friendly agricultural system.
Engineering in Sheffield has always worked very closely, very successfully with a whole load of industries, some that are labelled as environmental research and some are perhaps less obvious in terms of the better utilisation of materials, improved manufacturing processes, the better use of waste and also the better use of energy. Very much manage the demand side. There are an enormous range of scales and mechanisms by which they can engage with us, from very small scale, very quick feasibility studies, through more established project-based work, through to fully fledged long-term industrial research centres.
One of the key projects that I'm leading at the moment is in the area of low-carbon supply chain, and that is a strategic initiatives and collaboration between 4 universities in the region to develop a new way of helping businesses and industry to decarbonize their supply chain. What we are doing is we accumulate our team of expertise from various departments, various faculty to address the key issues and key problems faced by industry. It's not just a group of researchers dreaming up problems. What we are doing is something really seriously relevant to what industry and businesses are facing at the moment.
What industry looking from university is new ideas, really. I think it's because of university have more freedom to look at various other ideas and options, and then with this knowledge we collaborate with them to transfer this into a more like exploitation of these new ideas. We're working with a number of industry partners on developing electric and hybrid electric vehicle technologies. In the UK, we're collaborating with Jaguar and also the Nissan, as well as Toyota. In Europe level, we collaborate with Fiat and Volkswagen. And in the past, we also collaborated with BMW and Renault. The technical challenge is really, I think, for the electromobility to work, to be accepted by the general public, then it's really how do you make it very safe, reliable, and very cost effective. One of the benefits of collaborating with universities, because you can see we have a range of facilities and we can effectively making prototypes and demonstrate not just in terms of academic theoretical research, but also actually in the laboratory testing conditions. That is a necessary step in order to transfer specific ideas into a successful product.
We work a lot with the aerospace industry. We've always had very long-standing links with the likes of Rolls-Royce, Boeing. So in example of Rolls-Royce, we have a wide range of research looking at everything from improved and new fuels through to architectures and technologies for engines perhaps in 20 years' time. So the adoption of electrical systems onto engines, electrical systems onto aircraft to improve energy efficiency, reduce the carbon footprint of air transport.
This is actually a prototype machine which is designed for aerospace application. It is 250 kilowatt. This is quite unique. This probably is why we actually get more interested partners because these are absolutely essential in order to demonstrate your principle. Without it, you will not be able to really show that everything works.
We've worked a lot in consumer electronics with the likes of Bang & Olufsen and Philips, looking at improved efficiency for power supplies. Worked with building design people like Arup, looking at where we might be able to get better utilisation of energy within a building environment. So right across the spectrum.
The kind of businesses that we are working very closely with includes companies such as Rolls-Royce, DLA Piper, Unilever, Tata Steel, Sheffield Forgemaster. There are enormous amount of benefits in working closely with the university because the university provides a whole mix of different expertise to help various stakeholders in the society, whether this is government or businesses or industry. It is very important that these 3 key entities should be working much more closely together in this partnership.
Sustainable design today is very important. Today buildings are the biggest contributor towards global warming, and I manage 2 master programs with a main focus on sustainable architecture, at the same time heading a research center called Building Environments Analysis Unit. When focusing on sustainable design, we have to make sure that all our new build is properly designed accordingly with low carbon agenda. 3 key areas for sustainable design in buildings are the people, the users, the technologies, the services and the building fabric. University has the expertise to be able to bring applications, tool development One of the good things that the university is putting in place is to actually bring different disciplines, different research centres existing within the university into one place to allow them to interact and collaborate on interdisciplinary projects.
I think increasingly psychology is being recognised as a major component of the broader research that we're doing here in energy and environment. And so we are working with people in disciplines such as architecture, management, also some of the engineering disciplines in order to give a more holistic understanding on some of these issues.
Currently we are working with a local firm, which is a green energy centre, and the idea is to implement a way of reporting an energy master plan. On another project we are working with a big consultant firm, London-based firm, which is Hilson Moran, looking at the tall building sustainability indicator and be able to use their portfolio of projects for validation of the tool, and this could lead up to a spin-off company in the near future. We are also working with University Estate Department and using university buildings, particularly new ones such as this one, ICOS building, as a case study for our post-occupancy evaluation. One of the great things that the University of Sheffield is doing is to invest in their estate and building such buildings with the sustainable features, and in this particular building is the atrium. Space is created to drive the ventilation using the solar south-facing active facade space, and at the same time with features like maximizing the daylighting within the building and within the atrium space that we're looking at.
I think there's been a lot of focus really on developing very innovative technologies in order to, for example, reduce greenhouse gas emissions from power generation. But you can have the best technology in the world, but if people don't like it or don't know how to use it, then you're going to actually struggle to deploy it in the sort of numbers required to actually have the impact that you want. So where psychology comes in is understanding some of the principles behind the choices that people make, some of the principles behind how people respond to environmental changes. In line with our desires to decarbonise electricity generation in the UK, a number of new technologies are coming online. For example, carbon capture and storage is one of them, wind turbines as well. If the public don't like them in their local vicinity, or in terms of things like smart metering, if people don't know how to respond to the energy use information that they're being presented, then these technologies are really not going to have the impact that is really required in order to mitigate the threats of climate change. Some recent work that I'm doing has been finding out how the public are responding to carbon capture and storage technology. One of the main beliefs, I think, within industry is that the principal reason why people oppose things is simple NIMBYism, not in my backyardism. The picture is a bit more complex than that, and people will oppose local facilities for a number of different reasons. And what we're increasingly finding is that more involvement, more engagement with communities is fundamental really to the success of some of these interventions. I'm forming collaborations with members of other disciplines, other faculties, and so there is a clear engineering element there. Clearly the work that I do is only part of the puzzle. The introduction of these newer technologies, what are the obstacles and barriers to their uptake? And so here I think there is a clear union between psychology and engineering.
I think the growth and the future for low carbon sector research and innovation is going to be even more significant in the near future. We have already started seeing new businesses set up. We have started to see university designing training courses to address these skills need. The government and industry in the UK working together with Sheffield will have a lot to offer to really be able to prepare the future generation in this pathway.
We have a unique combination of skills in terms of fundamental science, how that science is applied, and how it pitches into the broader world of research and commerce. And that's the right reason to come to somewhere like the University of Sheffield to further your research goals.